Segment 4 is going to be stoichiometry with gases. So you might have to go back and revisit chapter was it 5, I think it was, when we did stoichiometry in the mole, and then come back and take a look at this. So we're going to take what we've learned in gases, excuse me, and look at PIV inert, PV equals nRT, which is what we just finished up with. We're going to talk about STP and how the mole can be related back to gases. So that will be this entire segment. So it's not a lot of slides, but it is a lot of information. So again, we'll be focusing on stoichiometry and gases. And you might have to go back, and it looks like I was correct according to this slide. Chapter 5. Now, when you're at STP, standard temperature and pressure, your conditions automatically have to be 0 degrees C and 1 atmosphere, which means when we're at STP, there's a direct correlation between volume and moles, and that's going to be 22.4 liters is equal to 1 mole. So that'd be our conversion. So now if you remember when we were looking at stoichiometry, there was 3 steps, right? In our first step, we were going to go mass to mole. In our second step, we were going to go mole to mole. And then our last step would be mole to mass, right? So what we're looking at changing are these 2 end steps. So this step in the middle will always be mole to mole, right? So you're always going to have moles of A going to moles of B. And again, this is going to be based on our balanced equation. So none of that stuff is going to change in the middle, right? It's these ends that can change. So we don't always have grams, right? We don't always have mass. Sometimes we need to work with gases or even liquids. And so that's where these other 2 steps are going to start to change. Now, what this slide is telling us is that if we are at STP, so if we've met these conditions, and in the question you'll be told that. I've got a sample question coming up next, right? So I do have an example coming. If we're at STP, then automatically we get to use this 22.4 liters per mole. Now I've also posted up in the student resources, you have your mole calculation sheet. And so if you remember looking at that, we had particle at the top, we had mole in the middle, we had mass at the bottom. And then there were these 2 wings where we related everything to mole. Now one side, I believe it was going to be the left, is going to be gases. And so you'll see that we have STP or PIV inert. And over here we had solutions. So again, if you didn't print that out yet, you might want to grab that. Remember, you'll be taking these tests online, and that's a sheet you can use. And so you want that at your disposal when you go to sit down and take that exam. Now the questions, again, will tell you you're at STP. So we say how many liters of O2 at STP, so there it is, that tells us our conditions, are required to produce 20.3 grams of H2O. So here we're going to have a mass, we're figuring out how much water we can produce, and we want to know how much oxygen we're going to need. So we're going to start it off just like we did before. We're going to start with 20.3 grams. 20.3 grams, and that's going to be of H2O. Now my first step, just like before, is to get that into moles. So 1 mole of H2O will go on top, and we're going to use our periodic table. We'll get our molar mass just like we did back in chapter 5. This is going to be 18.02 grams. Now remember, I got that because oxygen is going to be 16 grams. I'm using hydrogen at 1.01. Some periodic tables will be 1.008. Again, that's going to wash out in the sig figs. We're not going to have to worry about getting that precise, that accurate. Okay, the next step, we're going to do mole to mole just like we did before. Lo and behold, I don't have a balanced equation. So I'm going to go back and think about this reaction then. How many liters of O2 at STP are required to produce water? So obviously I'm going to take H2, I'm going to combine it with O2, and I'm going to make water. I'm going to pause here for a second and let you balance that, because you should be able to do that pretty readily at this point. All right, so once you've balanced it, you know you're going to need 2H2, you're going to need 2H2O, and now we have our molar equivalents here. So again, we're trying to get from water, so we're going to put water in the bottom here. So it's going to be 2 moles, 2 moles of H2O. And we want to get to O2 gas, so that's going to be 1 mole on top, 1 mole of O2. All right, and now here comes the new piece. So here, we're not looking for a mass of oxygen, we want to know a volume, and we're going to treat it like a gas, and we're going to be at STP, which means for every 1 mole of O2. Now, this equation over here, this equality, it doesn't care what kind of gas you have. That's the beautiful part. So it doesn't matter what the gas is, ammonia gas, oxygen gas, chlorine gas, argon, whatever the gas is, it's always going to be 22.4 liters per mole. So that means up here then, we're going to use 22.4 liters. And now we'll get out our calculator and we'll just run the math. So we're going to take 20.3 grams. We're going to divide that by 18.02. That tells us how many moles. We're going to multiply that by 1. We're going to divide that by 2. That's going to tell us how many moles of oxygen we're going to need. And then we're going to multiply that by 22.4. And that's telling us we're going to need 12.61709121 liters of gas. Now I'm going to pay attention to my sig figs here. I've got 3 going in, which means I'm going to have 3 coming out, which means my final answer then is going to be 12.6 liters of O2 gas. And that's our final answer. All right, so again, that's when we're at STP. Now, what happens when we're not at STP? Well, the key here is the reaction still has to happen in moles. It's still going to be 3 steps, but now you're just going to have more information given to you. So now let's say it's the beginning, okay? If I want to know how much gas, I'm going to change that to moles. I'll use the ideal gas law where N equals PV divided by RT. If I want to know how much gas, that means I'm looking for volume. And so that means I'm going to use moles times RT divided by P. So again, these would be the 2 steps, right? So if I'm in the first step and I'm starting with a gas, this is the one I'm going to want to use. If it's the last step, like we just did, then that means I'm going to want to know a volume, and that means that's the equation I'm going to use. So for instance, let's take a look at an example problem. HCl gas can be formed by the following reaction. So we're going to take 2 sodium chloride, we're going to mix it with strong acid, and that's going to produce HCl as a gas, and then sodium sulfate. Now, what mass of sodium chloride is needed to produce 340 milliliters of HCl at 1.51 atmospheres at 20 degrees C? Now notice you don't see the STP, and not only that, they've given us the conditions. So rather than being at 0 degrees C, we're at 20 degrees C. Rather than being at 1 atmosphere, we actually have some pressure there at 1.51 atmospheres. So what we're going to do then is we're going to figure out which PivNert side we need to answer this question. So remember, it's based on PivNert. PV is equal to nRT. And now we know it's a stoichiometry problem, so we know we're going to need 3 steps. So now we just got to figure out which step is it we're after. Well, if we're looking for the mass of sodium chloride, then that means most likely that's the 3rd step, right? So we're not looking for that. The middle step we know is going to be based on the balancing that's already been done for us. Now remind you that, on the exam, you'll probably have to do that yourself, right? So don't be shocked that it might be a word problem that says what mass of an ACL is needed to produce blah, 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 if sodium chloride is treated with H2SO4, right? Sulfuric acid. So at that point, you might have to know those names, figure out the reaction, see that it's a double replacement, then balance it, then go on to answer this question. Okay, so don't get confused by these things. You've learned all of these steps. It's just a matter of understanding which piece to use, which tool to pull out of the toolbox to get that job done. And then think about it as small little jobs. Don't think about it as one big job. It can get overwhelming. All right, so what is the mass of NaCl needed to produce this? So we know we're going to need to figure out all of this, right? And we know we're looking for HCl. We don't see how many moles of HCl. They've given us everything else. So we're going to rearrange this to solve for mole. So N is equal to PV divided by RT. Now we're just going to plug and chug into this piece to get our moles. Then we'll take our moles into that 3-step process. Well, actually, it'll be the last 2 steps of that process. And that's going to give us our answer. So let's see, we have 1.51 atmospheres. So moles is going to equal 1.51 atmospheres. times our volume, which is 340 milliliters. We're going to change that to liters real quick. Just divide that by 1,000. So that's going to be times, I'm running out of space here. Well, let's make some more room. Not exactly sure how I'm going to make more room on the slide, but we're going to. So we're going to say equals, this was 1.51 atmospheres. We're going to multiply that by 0.34 liters. Remember, that's only 2 sig figs. Want to keep that in mind. We're going to divide that by R. So let's see, we're going to be in degrees C, which we're going to convert to Kelvin. We're in atmospheres, which means we're going to use the 0.0821. Now remember, that's going to be based on the atmospheres. I'm not going to write out all those units. I just said I was struggling for space here. It's also Kelvin, so I'm going to have to add my 273 to that. So this is going to be 293 Kelvin. All right, so now moles of HCl is going to be equal to, again, we'll get the calculator out. Oops, calculator. We're going to take 1.51 times 0.34 divided by 0.00821 divided by 293, and that gives us 0.2, and we get 2 sig figs, so 2.1 mole. Now that's of HCl, so that's not answering our question. That's telling us how many moles of reactants we had. Remember, we have 2 more steps. So we're going to use our balanced chemical equation. This is moles of HCl. We want to know sodium chloride. So according to this, it's going to be 2 moles of HCl on the bottom, 2 moles of NaCl on top, and then last but not least, they want to know how many grams. For every 1 mole of NaCl, it's going to be, I believe it's like 59, but we'll get the calculator out and do it. So let's see, 22.99 plus 35.45 gives me 58.44. Again, that came from the periodic table, just like we did in chapter 5. And now finally, 0.21 times 2 divided by 2 times 58.44 gives me 2 sig figs, 12 grams. So that equation then is going to make us 12 grams of salt. All right. Hopefully I didn't get too fast there. If I did, again, just go back in. Remember, it's a video. You can slow it down, take a look at each step. If you're still confused by this, make sure you get a hold of me. I know these can get tedious and long. Again, it was only 6 slides, but we're already at the 13-minute mark. And I still have one more example for us. So our last example, I'm going to take that same equation, and now I'm going to ask you what volume of HCl gas at 25 degrees C and 715 millimeters of mercury will be generated if 10.2 grams of sodium chloride react. So now we're just going to take it backwards, right? So we're going to start like we normally would and take our 10.2 grams of sodium chloride and start there. I'm going to give you a little break right here to pause. I would like you to work this problem on your own. Then once you've got an answer, come back and take a look at how I worked it out. Your steps don't have to be exact, but you should be able to follow along with each step and match up your own work, and hopefully you'll come out to the same answer, or at least within sig figs, you'll come to a close answer. All right, so again, here's a little pause second for you. All right, hopefully you paused, and now you're coming back to this. You've got an answer, and you just want to just make sure your answer is the same. All right, so again, it's always a 3-step process, but I'm going to start with one step, then the next step. I'm going to take that moles, and instead of putting it in a step, I'm going to work that problem out because it's going to be Pivnert. All right, so 10.2 grams, that's of NaCl. I want to get into moles of NaCl, so I'm going to put mole on top here. We just figured out that it was 58.44 according to the periodic table. So that's going to go here. My second step is always based on the balanced equation, which we know is we're trying to get to HCl, so it's going to be 2 moles of NaCl on the bottom, 2 moles of HCl on top. And I'm going to go ahead and do the calculation at that point. All right, so at this point, I'm going to go ahead and calculate this out. I'm going to take 10.2 grams, divide by 58.44. It's 2 to 2. This tells me it's going to be 0.1, and I get 3 sig figs here, so 7.5 moles. And that's going to be of HCl. Now, they want to know what volume. So remember, we're starting with PIV inert. PV is equal to nRT. So now I want to know V. I'm going to divide through by P. So V is equal to P, which we're told is 715 millimeters of mercury. Whoops, that's going to be in the denominator. Mr. Caro makes mistakes. It's true. Oh no, and now that's on a recording. Oh well. I want to start with N, right? I want to start with my 0.175 moles on top. I'm going to multiply that by R. Now remember, I'm going to use I believe it was 62.4. I should look that up real quick here. I don't have a wrong answer for you. Let's see, yep, 62.36. So we'll use 62.4. That's going to be millimeters of mercury times liter divided by mole Kelvin. 25 degrees C, which is going to be 298 Kelvin. And now I'm going to divide all of that by 715 millimeters mercury. So my volume now will be in liters. And so we're going to take 0.175 times 62.4 times 298. We're going to divide that by 715. And it tells us we're going to make 4.3 sig figs. Yep, 3 sig figs, 5 liters. All right. Hopefully that worked out for you. Again, if not, go through the steps slowly, see how you're doing, see where your mistakes are, practice, practice, practice. If that's still a struggle, then be sure to get a hold of me. Either come to an office hour or make an appointment and see me. All right. Well, best of luck. That does conclude this chapter. So next we're going to be moving into solutions. So that's it for gases. That's a wrap. All right. Talk to you soon.